Hello, everyone, and welcome to C++ 102. This is week 4 with your lead instructor, Mr. Nelson LeKay. Nelson!
Jason.
How's it going? All right. And also joining us tonight, we've got Mr. Gavin Whitlock. Hey, Gavin.
Hello.
All right, so, what are we covering tonight, Nelson?
Well, I noticed a lot of people got super confused about the homework last week, so I want to give the opportunity. I left a lot of room open in this particular class for the opportunity to people to ask about Const-ness, and in addition, I will be going over actually implementing what I expected people to actually write during the homework, and talk about the decisions as to why certain things should be made const and certain things shouldn't be made const. As far as new stuff today, we aren't going to be writing any more code on the project just to give people a chance to catch up, but we will be talking about a few different odds and ends in C++ that is going to become very important. Specifically, we're going to be talking about the Copy Constructor and operator overloading. Now, we're also going to be wrapping up our discussion about const from last week. We'll be talking about const casting, const iterators, and const method overloading, because you can overload methods based solely on const-ness. And I will complain about that feature of the language once we get to talking about it. After that, like I said, we're going to go over copy constructors and operator overloading, talking about the different sort of ways to copy an object. And I think that's a very important concept in C++. That's important to, well, understand, especially once we start slinging around a bunch of different types of objects. But first, who has questions?
Now's the time.
Did anybody have any issues with the homework last week for const-ness?
Apparently not.
Really?
Well, either that or they're really, really long questions. If you could put them in the questions panel, that would be, well, correct. Emamoto said, I didn't do it, so no problem here. That's my approach to tax. Why haven't you paid tax? I didn't earn enough.
Is const-ness really all that beneficial? The answer is yes. Keeping in mind the things that should and should not be const will make your program more correct, because you are going to be explicitly declaring whether or not an object should be mutated or not. Keep in mind that mutation of data is the #1 cause for any possible bug ever in any imperative programming language, which of course includes C++. The opposite is true as well. The fewer things that can modify values, the fewer opportunities you have to modify values in a way that's incorrect. So const-ness is a very important concept, I believe, because it forces you as a developer to keep in mind where mutations of your data actually occur and prevent you from doing things that you shouldn't be allowed to do.
And worst of all, doing them accidentally and not noticing.
Right.
Because they're the worst sorts of bugs to find. The ones that, somewhere you've done something accidentally. And, it compiles, it builds, it runs, but you don't get the output that you expect.
Yep.
I wouldn't know about those, Justice Dude.
So some people are asking about the X and Y components of the position type, and we'll be covering that. I'm going to go through the homework in the entirety in a moment, which will include a discussion about how actually to do that. We did discuss constant fields before, and the biggest issue with constant fields is going to be that you cannot assign them to anything outside of the initialization list of the constructor. So we will be covering those. Are there any more sort of overarching questions about Const-ness? Because otherwise, I'm just going to jump in and start implementing the homework. Alrighty. Well, let's get working. Oh, great. Is it this one? I'm going to click on the right one, I swear. Oh, here we go. Okay, so the homework in for last week was to make as many things constant as possible. To sort of see, and I wanted people to, well, it's not that I wanted people to fail, but I wanted people to say, oh, I can make this constant, and then find out that, wait a sec, the nature of what it is I'm doing makes it so it can't be constant. And if the nature of something that you're doing makes it so that it can't be constant, then, well, don't make it constant. So let's talk about first the position, because the position should really be a very constant sort of class. Now you'll notice that in our entity, we do things like get position and set position. And for example, our entity returns a position reference with the get position method. Can anybody tell me why this could be a potential issue? Now, yes, we all know that position is in itself a mutable type, in that it doesn't provide any set accessors for either of its fields. But in general, without knowing the actual definition of position, can anybody tell me why line 10 is problematic? And apparently everybody's asleep today. Ooh, except for K7. Yes, we're returning a reference, meaning that we can reach into this position and modify it. Now again, we know that position is an immutable type regardless because it doesn't provide any set accessors. But if it weren't like that, and we didn't know the definition of position, line 10 should throw a huge red flag because we're returning a reference to something that's internal to identity. No bit of identity should be allowed to mutate the internal field of position that's provided by the getPosition method. So what that immediately sort of makes us want to do is make the return type of this getPosition method constant, so that we are returning a constant position reference. Also, on line 11, this is also problematic because, like what we discussed before with strings, you don't want to be able to mutate the position that was passed in to the setPosition method, although you don't want to result in a copy operation at the same time. The reason we're using references is so that we don't have to waste time copying members over and over and over again when we can just pass the reference. But because we are passing a reference, we are opening up the opportunity for us to introduce bugs with our code. So the fix is, of course, to make position constant. So once I've done that, if I jump back into main.cpp and fix my my position, get position, and my set position. Now the reason I'm fixing these two in main.cpp is that they are inherited from, but of course this being an interface by name, not necessarily by any language feature, I am referring to this as interface implementation. Our getPosition and setPosition methods are implementing the members that we define in identity, so we have to mirror their signatures by adding the const modifier to both the return type of getPosition and the parameter to setPosition. If I go ahead and build out, though, as you see, everything works up until this point. So that's the first bit as far as the get position and set position. If we jump into level, you'll notice that we are grabbing or we're doing a lot of copying actually with position. As you'll see right here with set tile, we'll want to go ahead and change these positions to references as well. But of course that will introduce some issues in addition to what we've already been dealing with. We don't currently access the, or we do to an extent, the position through a constant reference. As you see right here, this automatic implementation actually resulted in our position not being a constant reference, but being a copy. What we've essentially done is we've copied out position from get position. And we really do want that to be a reference. So what we're going to go ahead and do is modify line 69 to have a const position reference, which will introduce the first bit of an error. So I'm trying to sort of lead everybody to understanding what the importance of const methods are. We did get a question a little bit earlier about what the point of constant methods are. And let me go through what I was talking, or what we've been going over up until this point. We started with realizing that our position references that we're returning isn't what we should be doing, in addition to the position references that we take in as a parameter to the set position method. We really want const references so that there can be no possibility of us modifying that position. In level.cpp, it previously wasn't an issue because of the nature of implicit typing. What I had before was using the auto keyword, or implicit typing, which caused the position from the entity to be copied into this local variable. But that's not exactly the behavior that we're looking for right now. What we really want is to return a const position reference pose from the entity get position. That will make it so that we don't get a copy operation when we grab the position out of entities. But you'll immediately notice a problem. On line 70, we have two errors. Now that we're accessing a position object through a const reference, we can no longer invoke any of the methods on the position object that are not constant in themselves.
And these are this is a good process for when you're refactoring essentially code, when you're changing the layout without changing the effect, if you like. You're changing how it's doing it, but not what it's doing. Because when you know that you need to change one thing, change it and then build and see what errors you get, because that will point you to all the places that you've just broken. And generally speaking, you'll be doing the same fix to all of those places. Mm-hmm. In this case, you've turned a direct a copy into a reference. Right. So now you need to go through and do the same change in whatever places have been affected. And in terms of sort of time management, it's a good approach, because it's far quicker to do the same operation, 12 times in a row, than it is to sort of do one operation, do a different one, come back and work out and look at it and go, oh yeah, no, I need to do that here, and so forth. Yep. I just thought I'd stick that in there because this is a good pattern. And it's something I found that at the sort of 102, 103 point, you will end up doing a lot, because your instinct will be to write boilerplate code that gets it done however. And then you start seeing ways that you could improve it as you go through. Yes. All right. So now that I've corrected this code, it again, like Gavin said, it led me into two more errors. Now that's saying the object has type qualifiers that are not compatible with the member function. Way to go, C++, for not even pointing us into the right direction of fixing this error. But fortunately, I know exactly what it's telling me. What it's saying is that the position local variable is a constant reference, and we're trying to access non-constant methods on a constant reference, which is going to cause an error. Now, you can always go from a non-const to a const context,
but you can't go from a const context to a non-const context. Well, actually you can, but we'll talk about that later. So to fix this error, I'm going to have to make both getX and getY constant, which is simply a matter of going into the position.h header and adding the const modifier to both getX and getY. Now when I do a build, you'll notice that we get two errors. Again, I knew that these would become errors, but I wanted to point out the fact that we made a modification to code, we built, and we got errors. And what do the errors say? Well, if we jump into them, you'll notice that we didn't update the const definition of the CPP file, or whether or not either of these methods were const. So we can simply go ahead and do that and resolve the error. And now when we build, we get a successful build. So that was the first bit of going from recognizing a problem in identity, in that we were returning references but not const references, to getting constness to every level of the code that's required to make this work. So finishing up on position, I did get a few questions. People were like, why is it that this doesn't work? The const int x int y. The reason, the interesting thing about this though is it does. The reason it's working for me but not for other people, the fact that I can change both int x and int y to a constant, can anybody guess as to why this change worked for me but it might not have worked for other people? We've discussed this in depth in the past. But there is a very, very clear logical reason why I'm able to make this change, but other people won't, who think they have similar code when in fact they don't have similar code, because if they had similar code, they would get the exact same thing that I did. Yes, I'm a witch.
You're a witch?
Okay, the problem is that some people decided to implement their position constructor like this. So why doesn't this work? Why can't we do our position constructor like this? Why do we have to do our position constructor like this if both x and y are constant? Now keep in mind that this would be perfectly valid and workable code if both x and y were not constant. After taking off the const modifier, our code compiles completely. But by adding in the const modifier, our code now fails to compile. And in fact, the error message is actually pretty good in this case. It says position x must be initialized in constructor or base member initializer list. Of course, it's not saying why position x needs to be initialized in the constructor initialization list, but the reason it is, or it has to be, is because it's constant. Everything that's constant, every field that's constant, must be initialized in your constructor initialization list, period. Also notice that we get two other errors. L value specifies const object. Now that is a little bit of a more ugly error than I would have liked from the C++ compiler, but if you read it out loud a couple of times it should be fairly straightforward. The left value, or the value on the left of the assignment,
the one that you're assigning to,
yeah, specifies a const object, because you cannot change the value of a const object. Now quick back up to all those C# devs out there. Again, const does not mean the same thing in C++ as does C#. In fact, in this context, this const is akin to read-only, with one caveat. That caveat being you can only initialize it with the constructor initialization list. So that's another reason why you should use constructor initialization list. It's not just for performance, but it's also for instances where you can't do anything other than that, such as in the context of const fields or fields that are references. So you should really always use your initialization initialization list as much as possible. So I'm going to go ahead and specify both X and Y correctly. Wow, that would have been an interesting bug. In the initialization list, and as you see, everything works. Jeff, what's your error? Error, operator equals function is unavailable in position.
I don't see an equals that Nelson was using there.
Hold on, they're saying
Position.
line 37 of main. Which line are you referring to? Are you referring to this? Oh, right. I actually am getting an error there as well. Wow. There we go. Well, I was supposed to be getting an error in main, but unfortunately the compiler decided to lie to me, not recompile the main object file. I do want to point that out really quickly. When working in C++, this is a very common problem. Every CPP file in your C++ project gets turned into these OBJ files. So let me go ahead and click on all the OBJ files. So we have position and level. We don't have a main.obj because, well, my main's not compiling. But basically, every CPP file gets turned into an OBJ file. And the C++ compiler uses it for optimization. Because C++ compilation takes so ridiculously long, it's very good that the C++ compiler sort of caches the output of compiling CPP files into these OBJ files. However, on occasion, the C++ compiler will not detect that your source change actually modified an OBJ file and will not result in an actual recompilation. So the reason I wasn't getting an error previously that other people were getting is because my main.obj file wasn't being recompiled. If you notice, the way that I forced to recompile a main.obj was I added an extraneous space. Extraneous. I always say extraneous, but then you corrected me yesterday. Now I don't know. I added a space in this file, hit Control-S and Control-Shift-B, and that invalidated the OBJ file. A better way to do it would simply to do a debug, or sorry, Okay, well, unfortunately, there is not this particular menu item inside of the Express edition of C++, but you should be able to go to the build menu, hit clean solution, and then hit rebuild solution. So Control-Alt-F7 does nothing in Express.
Somebody's saying Rollinson said Open Solution Explorer.
Okay, so if you right-click on the project, you can go to Project Only, and then I can say Clean, which will delete all the OBJ files. Or it's supposed to delete all the OBJ files. There we go. So see, this is now the result of a clean. And now we can right-click on this, go to Project Only, and say Rebuild. Okay, so now I'm getting an error. Operator equals function is unavailable in position. Now, there's a few ways to go about this particular issue.
Jeff did say, what's the difference between the rebuild and build commands?
A rebuild will force a rebuild, as in it will completely rebuild the entire project, whereas a build will only attempt to build things that haven't previously been built, which was the core of my issue, in that it thought main.obj was up to date when in fact it wasn't. I typically do a clean and then a rebuild for the same reasons why I hit Control-C multiple times when copying something. I mean, it's just a habit. I really like to know that I've nuked every possible intermediate file out of that folder.
Cool. So how do we fix this bug?
Well, this particular issue will actually result in a little bit discussion about some operator overloading stuff and the idea of copying. So
Shiny.
Yes, but I will be ignoring this for now. That is a slight thing that I overlooked at the time, but we will be discussing how to fix this particular issue later. So in the meantime, I'm just going to continue I'm just going to leave it as is for the moment. Okay, so if we go ahead and jump into other things that we can look at for making Const-ness, we've worked on our iEntity a little bit. We have our collider update method, our set position, our get position. Now, again, the idea was to make as many things constant as possible, which doesn't necessarily mean make as many things constant as will compile, but make everything as constant that makes sense to. For example, the getCharacter method should really be constant. I should be able to retrieve the character of an entity through a const entity reference. Same with getPosition. GetPosition should be constant because I should be able to retrieve the position through a const entity reference. SetPosition, collide, and update, though, are different. These methods are expected to have side effects. These methods are expected to do some sort of state mutation. Some people are asking, too constant a method? Yes. Notice how this bit is simply saying the return type is a const position reference, whereas this bit is saying that the method itself is constant. Just like right here, the getCharacter, we have constant definition right there. So setPosition cannot be constant for obvious reasons. Collide and update, although we aren't doing anything in either collide or update, they should really be constant. Or they should really be non-constant.
Yeah.
And this isn't something, again, this isn't a matter of what will compile, it's what will make sense. Does it make sense for a collision to not edit anything within this object? And the answer is no. A collision should really be allowed to make modifications to the object itself.
Otherwise, you'd be better off not checking for collision.
Right. And same with update. I mean, what's the point of an update method that doesn't do any state mutation?
This also goes back to the whole idea of naming your methods sensibly. In this case, you've got collide, you're colliding, you're updating. These are verbs. They're doing things.
Right.
And setting position. That you're doing something. Whereas position is a noun. If you're getting the position, you're not doing anything with the position. Just getting it.
Yep.
That made more sense in my head. But
No, it made sense. I'm not going to worry about returning a const character because there's no reason to return a const character. There's just no reason to. It's not going to affect anything. Okay, so that means I'm going to have to update my methods up here. So getCharacter is now constant. GetPosition is now constant. And that's it. So now we should only have one more error left, and that's the error that we are going to be talking about here shortly. Or at least once we get done working with everything else.
So William had a question.
Okay.
He said, so a const at the end of the method means nothing in the method gets changed?
Well, yes.
Gets changed?
A const on the method definition itself means that the method may not mutate anything inside of the object itself. It means that that method may not edit anything inside of that class. Alright, so let's look at tile. What can we do with tile? Well, we can get the character. I'm going to go ahead and specify that as const. Enter, I'm certainly not going to leave const. However, can enter is kind of up in the air. I could argue either way that this method should or should not be const. I'm going to leave it as non-constant, however. And the reason is because keep in mind that Const-ness can introduce the possibility of locking yourself out of implementing specific features. For example, if canEnter were const, I wouldn't be allowed to count how many times an entity has entered the room and then deny them entrance after X amount of time. That would preclude me from actually doing interesting game logic.
Or even preclude.
That's the one.
So presumably it would be preferable to, if in situations where you're unsure, to make it const until it is problematic for it to be const, i.e. err on the side of caution.
Well, I would actually err on the side of caution on the other way around. I would err on the fact that this method, I don't want to remove the ability for me to represent specific game logic.
No, what I would, okay. I was kind of thinking in terms of, well, like with the whole public-private, make it, if you're not sure whether you need it public, make it private until it becomes necessary to make it public. I was kind of following that logic.
Yeah, it's something good to point out because it's something good.
Sorry, Karen.
It's something good to point out because a lot of people do make the mistake of using constant more than they should. Now, it is a great concept, and it does lead to code that is easier to reason about, but it can be overused. And in the places where it becomes overused, you lock yourself out of the ability of writing your code. You kind of code yourself into a corner. So that's why I'm not making canEnter constant, because I can foresee valid cases within the definition of what this interface does, in which making it constant will make it impossible for me to express certain game logic.
And yes, mutable means you can change it, the opposite being immutable.
Yes.
These are just words that mean things.
Seems like the only good place to make methods const are with getters. Almost any getter that you ever have should always be constant. I can't think of an instance where a getter shouldn't be constant, and there are some instances where things that aren't getters should be constant, and if we run into any of those situations, we'll discuss them.
And actually, probably that's a good indicator. If you can't make if you've somehow written a getter that you don't want to make constant in order for what's in it to work, you've put too much in your getter.
Exactly, because per definition, you're not getting some information, you're changing information, which should not be using the language that a getter should use.
The rule of thumb I learned early on was just that, the only code really that should be in getters or setters is validation.
Yeah.
And nothing else.
Well, and sometimes it sometimes is useful to do some computation with getters, but they should never mutate the state of the object. For example, you might have a class that has a first name and a last name, and then it might have a get full name method that simply returns the first name plus the last name. That's perfectly, acceptable to do inside of a getter, and there are a few cases where the logic is appropriate, but that logic should never cause side effects ever, period, end of story. If that logic reaches out to a database, if that logic reads from a file, if that logic mutates a local variable, you don't have a getter, you have a method that returns a value. Getting cannot instantiate abstract class errors. Well, guess what? If I go ahead and do a Control-Shift-B, I should get that same error as well. Can anybody guess why? Why I'm getting...
Because you can't instantiate abstract classes?
It says basic tile cannot instantiate abstract class. Why am I getting the error?
Because you cannot instantiate abstract classes.
Yes, but why is basic tile now abstract?
I think it's due to the following members.
Well,
I'm trying to make a point, and, it's the point I've basically been making this week, is this week's Gav's point. Read the errors that you are given, and they will tell you things.
Well, yeah, and pretty much exactly what Gav said. I cannot instantiate an abstract class due to itile get character const is abstract. Why is itile get character const abstract? I could have sworn I implemented that before. Let's go look at basic tile. Ooh, there's our get character, but it's missing something. I changed the interface definition to indicate that this method is const, but I didn't change the actual implementation. And a non-const method is actually completely different from a const method. So by specifying const, we now get compilation up to the point of the error that I'm strategically avoiding until talking about later. Alright, so those are our tiles and our entities, and so, you know, that's awesome and stuff. I'm not going to make can enter or enter. I'm not going to make these parameters constant. And I'm not going to make them constant because I could foresee some mutation happening through either one of these members. I reserve the right to change my mind later. But for now, because we don't have some important game pieces or some important object-oriented pieces in our application, that will prevent us from performing certain logic as well that we might want to perform in either one of those methods.
Somebody did ask, can a const method modify an object within a member vector?
What?
If they've got a member vector, a list, can a const method modify an object within that vector? Don't ask me, I'm just reading it out.
Can a const method modify an object within a member vector? I think I know what he might be saying. Something like... Let me see if this is his actual question. Let's write it out. Something like this. Who asked that? Chris. So are you asking about something like this?
There's a clue to the answer up line 14, I think.
Yeah. No, just try to modify a value of an object already in the vector. Okay, so something like that.
Assuming it actually had anything in it.
Right. Well, let me call a non-const method on the object in the vector. Oh! Well, that could be because of copying. So, for example, notice how I have a vector as a member in Bleh. Let's say I go ahead and write a class called Hey, and Hey has a non-const method called non-const. And now I have a vector of Heys, and then I have a method called Whoa that invokes Heys at 0.nonconst. Now, oh, I have to make it const first. Well, even this, though, you'll notice that we can't access that object. The error has type qualifiers that are not compatible with the member function. So I'm not exactly sure what you are referring to. You might have to post your code on GitHub or Pastebin. Because I don't know how you could get away with that.
Well, do you want to carry on for now and come back to that in the break?
Yeah. Okay, so for level, what am I going to do? I'm going to go ahead and say get width is constant and get height is constant. Everything else I'm going to leave non-const. Actually, just for whatever, I'm going to make the get index for xy constant as well, because, well, it should be. in all honesty. All it does is a simple computation. Even though this isn't a publicly facing method, I feel that if something really should be constant, it should be constant, if you know what I mean. So now I'm going to jump into level. Modify my get width and get height methods to be constant, as well as my get index for xy. And everything is good.
Now, did you see William's question that just came in?
In the can enter method, why didn't we make identity reference a const? For the can enter, I'm not making it a const in this particular case because of the possibility of the future design necessitating features that could be that could require the ability to mutate the entity on can enter. For example, if my tile was only enterable twice, I would have to keep track of how many times an entity has entered the tile, and to do that, it would have to mutate data. You shouldn't code yourself into a corner with const. Now, in the case of a system that's more fleshed out, that's when you can start making these decisions, again, with a little bit more confidence. But the way that the system is currently looking, and the code that we currently have written, I would not have the confidence of making that parameter constant or making this method constant or the parameter constant, because I could foresee situations that would cause issues. No, the entity wouldn't have a counter on it. I would have like a map, like use an STL map to keep track of all the entities and how many times they've entered.
And the same goes for enter as well, presumably.
Right.
And that was a good question, by the way. I'd been kind of wondering that, but that's my definition of a good question. Somebody asking something that I had been getting.
Craig fell asleep. Am I that boring?
Yes. Oh. Sorry, was that rhetorical?
Oh.
Well, Nelson, I mean, it might be about time that we go and give everyone a break and, let them stretch their legs. And
yeah, if you guys have any more questions, post them. We will be talking a little bit about fixing this bug. We will be talking about copy constructors, overloading the equals operator, and overloading other operators, such as the comma operator, which is overloadable. So, go ahead and pause it.
Cool.
Okay, and we're back. One of the problems about writing code in two different languages that are so similar is that you occasionally find yourself in positions where you take the concept of one language and mentally sort of project it on your knowledge of another language. And although that doesn't happen as often as it used to after working with these two languages for so long, I did mistakenly associate an aspect of C# and projected that aspect into my knowledge of C++, temporarily causing a lapse of judgment. Lapse of judgment.
That was a lapse in your pronunciation of lapse. And presumably we're looking at your position.h file. Presumably that's where it took place.
Correct. We're going to be...
Can anyone...
Yeah, can anybody tell me...
I just wondered if anyone could spot it of their own.
The funny thing was people were mentioning the error earlier, and I didn't get the error because of my my object files not getting updated. And then when I did, I was like, oh no, I'm going to have to backtrack on something. So this is me backtracking on something. What's the problem with this code, and why is it a problem?
It's C# code, apparently.
Well, the problem is that I declared both these fields as constant. Now, why that's an issue may not be very apparent right now, but it will become apparent very, very shortly once we talk about the assignment operator and the copy constructor. So I'm going to go ahead and make these two fields non-const and successfully build my project.
But you'll leave the getters, obviously, as const.
Oh, exactly. Yeah, I'm going to leave my getters const, but I'm not going to make my fields const.
It is ironic that that's the one area where people were having issues, it seems, in the homework.
Well, yeah, but guess what? Today we're going to learn exactly why this is a problem, and hopefully establish a good mental model for people. So that's really about it for now. These are the things that I would make constant. If people made things such as tiles or entities constant, I'm not going to knock people for that.
Yeah, actually, that's a good point, and as you've led off, and I'll bring it up now. People don't need to panic that, they didn't do the exact same thing that Nelson did, or they did slightly short. Where a homework is basically a best guess, if you make what you think should be constant, as opposed to there are 9 things that should be constant, and do those. Yeah, it was an exercise. So on that basis, this is more about submission than, actually having 100% the same as Nelson, given that Nelson didn't even get the 100% the same as Nelson.
Well, yes, and Nelson will be backpedaling on some of these things later on when we have more of a more of a context to describe the constness of our variables. But I am going to go ahead and jump out of this project. We're going to start working on another project right now, and we're going to be taking a look at some new interesting things. Now, I really quickly wanted to talk about some things that we didn't get to cover last week. And they're just sort of filler sort of things. So I wanted to leave them out because a lot of people got confused. And because a lot of people got confused, I sort of left a few straightforward things out for this week while people will be paying attention. So the first thing I'm going to be talking about is the Const Cast. So let's say I have a class position. And let's say he has a private int x, int y. Let's say he has
a private int x, int y.
What?
Well, you said let's say. So I was saying it.
Well, you said correctly.
I did. Because I can read.
I want my auto properties. Okay, so now we have this awesome position. But let's say we have a method that takes in a position called ble and takes in a const position reference. And let's say we have a position defined as a local variable in main called pose. And we say pose set x 10, pose set y 40, and then we invoke ble with pose. Everything should look fine up until this point. But some of the things that we have, or some potential issues that we have, or not even potential issues, per design, ble may not access set x or set y on position. I may not do position set x 10. I cannot do this because I'm accessing this through a constant object and not through an object that can be mutable. However, there is a way.
Can anybody guess?
There is a way for me to invoke set x without changing the signature of ble. Can anybody guess as to what that syntax would look like? Nope, not mutable.
Did you see what I put in the questions?
Yes, I did see.
Wouldn't it be great if you could just do that?
Nope, not static. Actually, Rolling Stone got it right. No, not comment out.
That'd work. The clue was in the title. He said, now we're going to talk about Const Cast.
What's the output to this program? Anybody? Output, go. Okay, when I hit F5, what I get is 100. How did that happen? Well, you'll notice on line 21, I perform a const cast. So keep in mind, there is an implicit conversion from any non-const type to its corresponding const type, but there is no implicit conversion between a const type to its corresponding non-const type.
Why is that?
Well, because it's silly. It breaks the rules. If you have a const object, you should only use it in a const context, period. Otherwise, why are you using const objects? So in C++, because of the use of const getting people sort of trapped in corners, and especially people of, third-party application developers, you using code that you can't modify or using third-party code or whatever. C++...
Yeah, so say you had some maths library or something that you were using for all the horrible calculations that was dealing in const values for some reason. You'd be at a dead end then because, just because of the way that had been coded, you wouldn't be able to use them.
Right. So C++ does give you a sort of opportunity to reverse const-ness, and that is through the const cast operator. And that's it. It's just a way to reverse const-ness. If you find yourself using const cast often, or even at all, against code that you have written, then you are doing it wrong. And you should reconsider the things that you have constified in your code.
That's so not a word.
I just made it up.
I know, it's good, but I'm just saying.
Is it basically mapping position to position 2 in that example? Well, yeah. It's taking position and stripping away its constness and assigning it to a non-const reference. This code is bad, yes, but it's sometimes necessary. And something that I like with these classes is showing people some esoteric syntax that is actually used in production code that you will see. And I want people to fully understand what this syntax is, what it does, and why, if you're using it against code that you've written, you're probably doing something wrong. If you have written this code, then you should refactor it so you do not need a const cast.
In this case, if you've written whatever results in your pos, if pos was the result, because this is a get out of jail free card. If you know that something's there and you want to make it non-const, then you can explicitly do so. So, if assuming that pos was something that, rather than being set in the main, it came from some external library, that is a situation when you would want to do this, assuming you needed it to be non-const. Yes.
Yeah. You will be, because of improper design of other libraries, you'll be forced in positions where you need to unconstify something. And C++ gives you the opportunity to do that through this particular operator. So you can't change const, except when you can.
I think
And
what he
that's,
meant was, so you can't change const
EX,
except when you can.
EXCPT.
Yeah, EXCPT. Because otherwise, no, don't accept when you can. You must accept it, for it is so.
Yes, it shall be so. So, yes, yeah. I just want to show, again, this is just a little simple, straightforward thing that I want to show people. It's fun little syntax that can get you out of rough positions. But if you find yourself using this syntax, if you go around Googling, hey, I'm getting this error about const-ness, what should I do? And people are like, oh, use const cast. Well, you probably should refactor your code so you don't have to use it. And if you can't, then if you can't, then you could use Const Cast, I suppose, in situations where it's not possible for you to refactor the code to make it necessary. Okay, so how's everybody feeling about a Const Cast?
Utterly joyous.
Justice, what's your feelings about Const Cast? Because you said that you felt bad about them.
See, this isn't like a normal class. You whisper something in BuzzNet and we will ask you about it.
So you should know about it, just never use it. No, you should know about it. You should use it when appropriate. And if you find yourself using it, you should ask yourself if is there a way to not use it. In some instances, that answer will be no. In some instances, it'll be you must use this operator to do something you need to do. In which case, go for it. Use it. It's there for you to use. But every time you use Const Cast, ask yourself, is the reason I'm...
Yeah, should I be using this? Because it's the same as any other thing where it's a bit of a get out of jail free card, as I said. It essentially lets you do something that you probably shouldn't be doing. So when you find yourself using it, the first question, or anything else where the same thing applies, the first question you should ask is, hang on, I'm using this. I know that it's this, this lets me do something that I really shouldn't be doing. So is there a proper way of doing this that obviates the need for Const Cast? If the answer to that is no, which, the vast majority, or certainly the majority of cases, will be because you're dealing with someone else's code that is const-ified. Yeah, does that make sense?
Okay.
Yeah. And as Atomizer said, using Blair for an example, since it's code Nelson wrote, he can go ahead and refactor it to not use Const Cast.
Well, exactly. In this particular case, what I would do is say, well, I wrote this method originally assuming that I wasn't going to modify position that was passed into it, but then I decided later on that I really did want to modify the position of the object that was passed into it. So,
because it was a really boring game when the player was stuck on one spot.
So what I would do to fix this code is I would delete this const cast, have it access the parameter directly, and then simply remove the const modifier. I have now not only fixed the compiler error, but I've also informed every person who invokes this bleh method that I could potentially be modifying this parameter that they pass in. See, by saying const and then using a const cast, you are lying to everybody who uses this method. You're like, oh, no, I promise I'm not going to change this object. I promise I'm not going to do anything to it at all. And then the other code begrudgingly says, okay, here you go, have a constant reference. And then, you turn around and you...
rip its head off.
Yeah, you just pull it apart and mutate it, and then you throw it back to them and say, here, that's what you get for trusting me. So it really is sort of a lie. And the best way to refactor this code would be simply not to lie and say, I do want to have the opportunity to modify this. If you're not comfortable with me modifying this parameter, don't invoke me.
Maybe we just shouldn't see each other anymore. Cool. Well, hopefully that ludicrous example will help it stick in people's minds.
I love personifying code. Personifying code is my favorite thing to do.
The anthropomorphism of C++. Do you want to clop on to the next subject then?
Indeed. Okay. So let's talk about two things that are interesting. All right. We did get a question. Does const cast allow use of all methods? Well, yes. Of course it does. Const cast turns this constant variable into a non-constant variable, meaning we can access both constant and non-constant members of this particular object. Okay, so two more things that we're going to be talking about as far as Const-ness. You're going to love this, Gavin. I know you're going to love this. Output to program, go. What's the output of this program? Is it a compiler error? If it is, what's the compiler error? Otherwise, what is the output?
Was I right? Yes.
Look at line 28.
Oh, I didn't even see you type that.
Surprisingly, I'm not... Okay, so we get one compiler error. What else do we get?
Oh, yes, they're not a method group then. I totally failed to see the twos.
Oh.
I thought it was two overloads. Bleh. Yes.
We get a compiler error on line 13. That's good that we got a lot of compiler errors. Actually, I'm happy that people...
There's a lot of quick typists in this class.
Well, yeah, I'm happy people think that this is a compiler error. Because it really should be. Oh, derp. Hold on. Okay, let me back up.
Round two.
Okay, I'm glad people thought this was supposed to be a compiler error, because it really should be. But it's not. Waiting to see everybody's reaction to this not being a compiler error in BuzzNet right now.
Well, you see, given what I thought you'd written, was I right?
Well, yes.
That's good then. That makes me feel better.
Okay, anybody throwing up? Oh, right. I did say earlier that you can overload on Const-ness. I don't like being able to overload on Const-ness, but you can. Which means that in the C++ programming language, I can provide two implementations of a method that have the same parameter list, the same name, and only differ depending on Const-ness.
Yeah, that is horrible.
Which means that we could potentially get two different behaviors of the same method, depending on if what we're working with is a const value or a non-const value.
So, can you remove the 2 on line 18 now then, is what you're saying?
Line 18... Oh, right. As far as this? Well, this will...
Because in order for what you're... Yeah, that will end there, obviously.
That's going to invoke non-const both times. Because I can overload on...
Yeah, but what you were saying is you can overload... And you weren't. You had two different methods. You had a Blair and you had a Blair 2. They're two different methods as opposed to overloads of the same one.
And then that's also for demonstration purposes, because otherwise it would be very difficult to invoke the other method based off the difference in the overload. But just by supplying the const keyword in the method, you're providing a potential overload. And that overload will proc if you are accessing it through a const object.
It will proc.
Yes.
Is that good or bad?
It's a term that I picked up when I used to play Magic the Gathering. It will execute.
Right.
It will be invoked. It will happen.
Cool.
Okay, so let's talk about why they did this. There's an interesting reason why they did this.
Just because they knew you didn't like it. Specifically to wind you up.
Perhaps. Ah, what am I doing?
Failing to type, it would appear.
Yeah, I'm doing that a lot today, aren't I? What is the type of I on line 13? Can anybody tell me what the type of I on line 13 is? And when I say I, I'm referring to the implicitly typed local variable. What is the type? Tell me the type.
What would you have to replace on auto with on line 13?
Yep. Well, we're getting a lot of iterators, but that's not the complete story. Let's see if anybody can get this completely right. Closer, but that's not valid syntax.
Alligator.
No, allocator.
Oh, yes.
Xenolf. Nope. Tizer. Closer. Dual amp. That's close enough. Okay.
Yay.
What we'll get is a vector of string iterator.
And actually, Stuart nailed it down before you put it up.
He's missing the scope resolution.
Oh, yeah.
Isn't it const, though? Why would it be const? Is there the keyword const anywhere in my program?
So why would it be const? Because we're talking about constness. It was a 50-50 shot.
So that's the type, and I can prove that's the type by going back to implicit typing and hovering over, and noticing that I is an std vector iterator of std vector, std string, std allocator of std string, my base.
Hence, auto, which is only 4 characters.
Well, fortunately, there's a type def within iterator that actually grabs that for us, so we can just do vector of string iterator. So yeah. Okay. What is the type of I now?
Even longer. I'm guessing.
Tizer got it right. If you look closely, it is a const iterator, which means it is now a vector of string resolved to const iterator. By adding the const modifier to this method, the return type of the begin method changed behavior because of the nature of const method overloading. Because we are now accessing a vector through a const object reference, we actually get access to a different set of methods that have different sets of return types. Those return types returning const iterators as opposed to iterators. So is everybody... Wait, so how does I++ work if the iterator is const, or am I overthinking this? I think you are overthinking this a little bit. The constness of the iterator simply determines that you cannot modify the values that are inside the iterator, and that the iterator returns constant things. So you'll notice if I jump down to the this guy right here, if you look at its type, well, in this particular case, because I'm returning a const string, it doesn't matter as much. But notice right there that this operator is a const operator. You'll see right there. Just because something is constant, a method is constant, does not mean that we can't mutate local variables. We can still mutate local variables, which we're doing right here. I is an iterator that's copied into the stack frame of print, and we're using the increment operator to mutate a local variable that was declared here on line 13, which is perfectly valid to do in the context of constness. However, what the iterator allows us to do is the iterator is only going to allow us to do things in the constant context, as opposed to a non-constant context. So I really just wanted to point that out. That's about it for constness that I wanted to cover today and yesterday. We will be talking about constness more during the weeks in the future, and even weeks in further C++ courses, because it is a very massive subject with a lot of ramifications. But I hope I introduced people to the idea of constness, some of the rules in regards to constness, and hopefully made people less afraid of it so that we can actually use it to do good things later.
It's funny because initially we didn't use it because we needed to tell people why they should be scared of it.
Well, yes, and now that we've had the opportunity to cover the most scary aspects of it, I hope people are more or less comfortable with the concept of Const-ness. So how's everybody feeling? Someone's feeling gooder.
Yeah.
All right. So any questions, be sure to post in the questions panel because we are pretty much moving on to some very straightforward bits of the C++ language. I did promise people that we will be talking a little bit about the copy constructor and the assignment operator. So I do want to go ahead and cover that today. All right. So every single object I think C++ is a difficult language for everyone.
Yeah.
Every single object.
Nelson?
You what?
Oh dear.
Yeah, he
Nelson?
seems to have gone away from me too.
Hello?
All of a sudden there was a lot of hiss.
Hey, there you are.
Am I here?
Yeah.
All of a sudden there was just a lot of hiss.
Huh. Am I here? Does everybody hear me?
Yeah.
Yeah, we hear you now.
Yeah, I've been having Comcast issues actually this whole week where it decides to randomly drop me because, well, that's the service I get for, paying them money every month, is them randomly dropping me half the time. So anyway, let's hope that we can get through the rest of this without Comcast completely failing on me and talk about some of the stuff that C++ actually gives all of our objects. There are at least 2 invisible members on vector 2. Can anybody tell me what the 2 invisible members are? When I say invisible members, I mean members, real functions with real functionality that are being generated for us by default by the C++ compiler. Nope, not setters. Not git hashcode. There is no git hashcode. Yeah, copy constructor and assignment operator. Every class in C++ has what's called a copy constructor. Can anybody guess what a copy constructor does?
Yes. But just, did you know what Rolling Stone's answer was in BuzzNet? Because
What, Rolling Stone? Make donuts?
no, before that,
Oh.
4 lines up from that.
Oh, we're not talking about the destructor really in depth today.
But is that there though?
It's not particularly useful to think of it as there because regardless of whether or not there is code in it, it will always be fairly empty. The only thing it's going to be doing is calling the destructor of all of the fields inside that class. But I don't really want to talk about destructors because...
No, that's cool. It's just in terms of, the question that you'd asked.
Yeah.
About the being invisible.
Yeah, well, that is true. But I only want to talk about the 2 invisible things we're going to be talking about today, which are the copy constructor and the assignment operator. So, can anybody tell me hold on. Let me go ahead and give it a... Can anybody tell me what the difference is between line 25 and line 27 and 28. What is the difference? All right, it looks like Atomizer got it right. Which one do you think is faster? Can anybody guess which one of these is faster? Yep, the copy. First of all, I want to back up just a little bit. Look at the completion list of my vector 2. Notice how there's a parameterless constructor, which I defined on line 11. There's a constructor that takes in 2 parameters, which I defined on line 13. And then, wow, hold on, there's another thing that I didn't even write. That's not even there. I don't see any constructor that takes in a const vector 2 reference. That is the copy constructor. The copy constructor will always take in a const reference of whatever type we're copying. So let's go over and break down the different method invocations that are going on right here. This is invoking the CTOR of vector 2 const vector 2 right hand side. This is invoking the CTOR of vector 2 and parameterless,
vector 2,
and then invoking the operator equals method that takes in a const vector 2 RHS. So there's a big difference here, and this is the big misunderstanding that people have about the difference between a copy constructor and assignment. A copy constructor is when you provide a thing to copy from within construction, which will typically be faster than doing this syntax right here, where we actually instantiate a vector 2. We invoke this line of code right here. Then, a line later, we invoke another thing that copies all the members out. So this is a copy constructor and this is assignment. Both the copy constructor and the assignment are generated for you.
Or the ability to use them is, you're saying?
Well, yeah, it's always is a copy constructor always created behind the scenes when a class is defined? Yes. So let's go ahead and actually implement the copy constructor and the assignment operator as the C++ compiler would. And let's see what they look like. To implement a copy constructor, you simply implement a constructor with a const value. That's it.
Vector 2.
You just have to take in a single parameter that's a const reference of whatever the enclosing type is. The C++ compiler, in this case, the copy constructor that it will generate looks like this. I use the RHS to stand for right-hand side. When doing operator overloading, it's a convention that I've just fallen in the habit of doing. So this is the exact copy constructor that the C++ compiler generates for us automatically. And this is the assignment operator that the C++ compiler will generate for us. And when I said that 5 seconds ago, I actually didn't mean it. I meant this is the actual assignment operator that C++ will generate for us.
Which makes sense.
Yes.
Or at least should do, you know.
And this is why it's faster, though, because in this case, the fields only get initialized once. How many times do the X and Y fields get initialized or assigned to between the lines of 38 and 39? They get assigned to twice. What about now? Well, this is a bad example because I'm using a primitive, but bear with me, pretend that x and y are vectors. If they were objects, how many times are x and y being initialized this time? Now we're pretending they're objects, so just bear with me. What happens is, in this case, what we do is we first invoke the parameterless constructor, which first, before the constructor even gets invoked, initializes our fields, if they're objects, which in this case they're not, bear with me. Then on line 15 and 16 we assign them. Then on line 28 and 29 we assign them again after line 41 procs.
See what Sire just put in, doesn't it?
After. Oh, well, obviously this isn't going to quite work. It's going to have to be something like that. So if the reference is pointing to ourselves, then we simply don't do anything. But, I mean, I don't want to worry about that code right now, actually, simply because that's kind of not the point at this moment in time. Okay, so given that this is what vector2 looks like, and given that these are the members that vector2 actually create, or the C++ compiler actually created for vector2, why is it impossible? Point me to the line of code that makes it impossible for me to declare x and y as constant.
I'm pointing.
Give me the line numbers, or line number, that makes it impossible for me to set these two fields to constant. Exactly. This is why we ran into the problem earlier. Because I declared these as constant, but the C++ compiler generates code that results in an error. Like literally, that's exactly what happened. I said this is constant. The C++ compiler generated code and was like, well, actually this code is not possible to be generated, so I'm not going to even worry about generating it. We cannot assign a vector2 to anything. We cannot copy it using the assignment operator. Now, we certainly can copy it using the copy constructor, because the copy constructor will use the initialization list, which of course is available for use when in the context of constant fields. How can I make this code compile?
Comments.
Someone tell me how to make this code compile.
Code better.
Without a Const Cast. Without making operator equals private. Actually, it's funny, this question is kind of like, this question is a little bit silly, but the answer I wanted to hear was simply delete lines 26 and 27. That makes the code compile. Given that, what is the output to this program? We get an error, we get a 0, we get an unknown. Oh, come on, guys, wake up. What's the output to this program? We get a 1.
Gerald.
We get a Gerald. We get a 0, we get another 1. So let's go ahead and hit F5 and see what happens. We get a 0. The reason we get a 0 is, let's walk through the execution of this code. We start off with initializing, instantiating a local variable called copy2 of type vector, using its default constructor. So if I go ahead and step into the default constructor, notice how we initialize both x and y to 0. Then we assign copy2 to vector2. Now let's jump into that code. Well,
Other way around.
Whichever.
Well, no, it's not whichever. You've completely reversed the point you're trying to make. We've assigned vector2 to copy2.
Yeah, we've assigned vector2 to copy2. Then we jump into our custom-defined operator equals, which, out of necessity, we could physically not do anything with this logic. There's no way for us to, without a const cast, of course. Which simply returns this and returns, which means that now copy2 still has an x and y as 0. So, that's why fields are difficult to make constant, because you can't use the same operators that you may be used to. I do really want to point out, though, to people that this sort of stuff is probably very confusing to C# developers. Because in C#, it's very rare that you do operations like this. However, in C++, you have to think about where your memory lives and who owns it, constantly.
Yeah, it's that whole ref value thing as well.
Yeah, and so when we do copy2 equals vector2, what we're in effect doing is we're saying take all the values of vector2 and place them into copy2. So why don't we get assignment errors with any other class that has const fields? You'll get an assignment error when trying to do an assignment. But you won't get an assignment error unless you try to attempt an assignment. And also keep in mind is that there's a difference between doing an assignment to a field and doing an assignment to a doing an assignment to a object and doing an assignment to a pointer, or doing an assignment to a reference, which you actually can't do, so ignore me. So you can never have a const fields. Oh, you could, but be very, very cognizant of the limitations of const fields. Don't treat them like read-only fields, as you would in C#. Of course, that's depending on what exactly it is you want your class to do. Keep in mind that vector2 is very much a value object. This object will be copied around. It'll be thrown all around our program all the time, copied and referenced and everything everywhere all the time. It's not like a level class or a game class or a player class, which those are things you really don't want to copy. It doesn't really make sense to copy a player. I mean, it might make sense to instantiate a new player. It doesn't really make any sense to copy a player.
Unless you've got mirror image spell.
Well, yeah.
Sorry, yes. Shut up.
Alrighty. So that's the copy constructor, and that's the assignment operator. Can anybody tell me? So keep in mind that what I have right here, on lines 17 and 18 and 19, and on lines 24 through 29, these are all things that are generated for us by the C++ compiler. These are exactly what the implementation of the C++ compiler's things do. Wow. Implementation of what the C++ compiler's generated members will do.
This is how the generated members are implemented.
By the C++ compiler.
With the exception of, yes, with the exception of this checking.
Yes. Why would you ever define your own copy constructor or define your own assignment operator?
You remember that L system project I had going?
I think Rolling Stone is becoming the new segfault. I might have to ban him from answering questions.
An honor indeed.
But we did have a question. People can still post answers in the BuzzNet, but I did have a question. So if I assigned a level to some other level and it had constant fields, I would get an error. Yeah, but I wouldn't assign one level to another level. I really wouldn't do that. Because once you start talking about complex entity types, things like accounts and players and users and levels and monsters, it doesn't really make sense to copy them around very often, if at all. because you really shouldn't do that. Those should be treated as instantiatable objects. Now, if you want a copy of a monster, then at that point you would change the way you thought of the problem. You would instantiate multiple monsters from the same source, some sort of factory method, as opposed to instantiating one monster and then repeatedly copying it around. That would be horribly inefficient. What about equals new? Is that different? Yeah, it is. It is kind of different. All the equals new does is instantiate or allocate memory on the heap as opposed to allocating memory on the stack. But the number one reason why you would use a copy constructor or an assignment operator is when dealing with dynamic memory. Now keep in mind, let's say I gave vector2's a name. I'm going to go ahead and delete those implementations. And then that. What's problematic about this code? Besides the fact it doesn't compile. Give me a sec. So what's problematic about this code? Does anybody have any guesses as to what could make this code problematic? Anybody? We got an equality. Anybody else? Wow, the chat room's dead. String passing could be deleted. Copying would copy the address instead of the actual string. Okay. The problematic aspect of this code is actually nothing. I love trick questions. This code is actually perfectly fine, and here's why. Because the copy constructor and the assignment operators are being generated by the C++ compiler, they appropriately defer to other objects, copy constructors, and assignment operators. Meaning that the copy constructor that will be generated by vector2 would appropriately invoke the copy constructor of string, just like the assignment operator of vector2 being generated would appropriately invoke the assignment operator of string. So when thinking about deciding whether or not you want to use it, you want to implement your own copy constructor and your own assignment operator, don't just think about it in terms of whether or not you're dealing with memory on the heap or not. Because we are. We are dealing with memory on the heap, this being a string. A string has a character pointer. But because it's wrapped up in a string object, and because the C++ compiler is smart enough to generate our code appropriately, this is not problematic, and this will be fine. However, if I had instead of a string, I had a character pointer, let's say a const character pointer. No, let's just do a character pointer. That's better. Now the code has been problematic, or become problematic, for two reasons. First of all, I'm not cleaning up the character pointer that was passed in. Well, first of all, I'm actually not even copying the name appropriately. What I should have done instead is said name equals new car, string length, name +1, stir cpy, name. Now this code has two problems. Or three if you want to count each individual member.
Doesn't that be 6?
No? What?
2 problems for each member.
No, well, no. Well, I hate the English language. First of all, I'm missing a destructor, so let me go ahead and implement that. Now tell me, what's the output to... Oh, well, of course. Give me one sec. Vect1. Let's do that. And let's do delete vect1, cout, vect2 dot get name. What's the output to this program? Line 20 has an error? I think this... Ooh. Oh, no, those are warnings. We get garbage and we get undefined. The correct answer is undefined. But I could get an exception. The reason why this is problematic is notice how vector2 is now dynamically instantiating memory. Now, it is appropriately deleting the memory. So you might be looking at this code and saying, hey, this vector2 class is awesome. It dynamically instantiates memory, which is fine. But more importantly, it also deallocates the memory when it's done with it. I mean, this class is just bulletproof. The fact is it isn't. And the reason it isn't is because both the copy constructor and the assignment operator for this class are going to point to the same bit of memory. Because the copy constructor generated by this class, and notice I am using the copy constructor on line 34, I'm not using the assignment operator. The copy constructor looks like this. This copy constructor is fine for x and y because both x and y are primitive value types. But the third aspect of the copy constructor is problematic because it is copying the pointer, not the data stored within or at the pointed to location. So this being what the C++ compiler will generate for us will cause problems because when I did do a copy operation on vec2 and then I deleted vec1 and then I tried to print out vec2.getName, I got an exception because it's not pointing to invalid memory. Or more appropriately, what's actually happening is when I returned this this character pointer as a string, it tried to instantiate a string with this character pointer, and then the strings constructor went, whoa, well, this is invalid. If I move the delete statement down, however, I do still get a bit of an error. A bit of an error. I love C++. So as you see, name is appropriately set to whoa. But we are still getting an access violation. I don't have the energy to debug at this particular moment in time. But essentially
There are many reasons why this shouldn't be done, essentially.
Exactly. And it's kind of getting away from the point here. So does everybody see why this copy constructor that was automatically generated by the compiler is incorrect? And does everybody see why implementing your own copy constructor is important?
You could just touch on the whole issue of how you can... I mean, because that's one of the things when you're defining how two things are, whether or not they're equal. In this particular case, you probably wouldn't want to consider the name in that at all.
No.
You know, because you'd want to know whether they were equal values. But anyway, sorry, that's dragging off the topic. So, did you have anything else on this section?
No. There are a few more things I want to talk about. Actually, really quickly. Is this code good? Or actually, hold on, let me fix the copy constructor first. Okay. So now I've fixed the copy constructor. Is there anything wrong with this code? Notice I did change main. don't think anybody trusts me anymore, as far as my questions. Well, come on, I'm trying to keep you guys awake. The problem with this code is that although I did fix the copy constructor, I didn't fix the assignment operator. The assignment operator is still broke, which is what I'm doing here on line 42. This is an assignment. This is not a copy operation. This is an assignment. So, before we go ahead and end today's lesson, there is one rule of C++ that is very important to keep in mind, and that's called the rule of three, not to be confused with the rule of thirds. But the C++ rule of three, can anybody guess what the C++ rule of three is, actually? Like,
I have quite a cynical guess of what it is. If you're doing something once or twice, that's fine. But if you find yourself writing out the same code 3 times, then you're doing something wrong. And you should make it into a method.
well, that's not a bad rule, but that's not what I was going for. The rule of three in C++ is that if you know for a fact that your code needs a copy constructor, an assignment operator, or a destructor, then it's very likely that you actually need all three.
That makes sense.
If you need a copy constructor, oh, hold on, let's start off with a destructor. If you need a destructor, you are most likely using unmanaged resources. Or sorry, well, all resources are unmanaged in C++, it being an unmanaged language. That means you are using resources that you need to clean up. If you are using resources that you need to clean up, then you're going to have to implement both the copy constructor or the assignment operator. Because...
Yes, because otherwise you wouldn't be able to create those things in order to have to clean them up afterwards.
Yeah, and you'll be pointing to the same resources. Like multiple copies will all be pointing to the same thing. If you are in a position where you do not want a copy constructor, let's say you still need a destructor. Let's say that your class opens up a file handle to the operating system, and when your class gets destroyed, it releases the handle. But let's say that you decide that, well, I don't really want a copy constructor or an assignment operator. Omitting them is not right. If you explicitly do not want a copy constructor or an assignment operator, this is the appropriate thing to do. Now, unfortunately, the compiler that I currently have does not support the equals delete syntax. That is a bit of syntax introduced in C++ 11. So for now, if you are working with a compiler that has more support, use equals delete to explicitly say that you are not providing an implementation to this method. Alternatively, if you are not on a compiler that supports that feature, simply just don't give it a body. No, don't even give it a body. Just leave it blank. Make it private and leave it blank. And what this is going to do is this is going to prevent the C++ compiler from generating either of these things and making them public. Which means now I get an error on line 40. Which is good. Because I've explicitly said that because of the nature of this class, I do not want it to be copyable. I should get a compiler error every time I attempt to copy it.
Cool.
All right, so I'm going to go ahead and go on break once more and let questions come in, and then that'll be the end of today. So I'm going to go ahead and pop. And we're back. So questions. Do you ever flowchart your object programs? I do, but I do in code. I think that I typically see code as being as succinct as most flowcharts. I have done actual drawing before as far as design, but not as often as some people think is useful. It really depends on how you conceptualize code, and I find that code is a lot easier to conceptualize as, well, code. If I want to see a particular design work out, I'll write code against classes and methods that don't even exist yet, just to see how the syntax would look. We're not doing move semantics. Please, no. Not this course. We will eventually. It's an interesting feature, but we're not going to. Have we gone over regular casting? Yes, in 101, I believe. We never went over static cast. Static cast is only used... static cast is only used when doing static casts. So static casts are only going to be used when you're trying to cast from a static thing to a non-static thing. They're not appropriate to be used for any other context. If you want to convert from a float to an int, then you're going to be using a normal cast, like people are already familiar with. So it's not that I have an opinion over between static cast and normal casting. It's that static casting and normal casting both provide two separate features that are used in two different scenarios. And apparently equals delete is not working on VS 2012. Okay, so I think that about wraps up everything I wanted to cover today. This was
Homework?
a bit of a short class. I wanted to introduce some fun things, some fun, easy things to conceptualize after kind of murdering everybody's brain last week. So I hope people have a better understanding of Const-ness. I hope people have taken away from this lesson the concept of a copy constructor and assignment, which are very important things. You have to know what the compiler does behind the scenes. I cannot stress this enough. When you see an assignment or when you see an object instantiation, you have to know what code is being invoked, what the compiler is going to do, and how that's going to interact with the rest of your code. Because when something fails, when you get a cryptic compiler error such as this, well, that's not really that cryptic, but still, when you get a cryptic compiler error, generally, you should really be able to conceptualize why you're getting this error. Why can't I make a copy of a vector 2 through an assignment operator if the fields are constant? I really want people to get a good mental model of Const-ness and how it relates to copy constructors and assignment operators. So that wraps it up. I want people, for homework this week, it's just going to basically be a repeat of next week. I know I already went over it during...
A repeat of next week.
Wow. Yes, actually, if you can pull that off, then you will win this course.
Things.
Yes. If you can submit next week's homework this week, I will give you a cookie. But in all honesty, it's just going to be, or in all seriousness, it's just going to be a repeat of last week, where I want people to sort of think about Const-ness and how it relates to their code and their design. So yeah.
Cool.
I think that's about it. So to all the future people watching, goodbye.
They will be able to do next week's homework, of course.
Well, yes. Well, if the future people are...
You're going to be giving out cookies.
Alrighty. So, yeah.
Bye.
Bye.
Bye.